All right, 7-4, multiplying and dividing radical expressions. Pretty straightforward. Lance, the one thing you need to know is you multiply inside with inside, outside with outside. Okay, it's not that difficult. If you want to write that down, you can. All right, but that is something that you guys learned in algebra. Okay, so what do I mean? Inside with inside, outside with outside. If I'm doing root 3 times 2, notice the root 3, all right, the 3 is on the inside and the 2 is on the outside. So I'm not going to multiply the 2 and the 3 to give me root 6. It's not the way it works. It's inside with inside, outside with outside. So notice the 2 is outside the square root and the 3 is inside, so it's just 2 root 3. Okay? Chris, do you see where I got that from? Now, when I do root 3 times the root 5, notice the 3 and the 5 are both inside the square root. That becomes root 15. Once I do this, I want to see, can I reduce what's inside these square root symbols? Can I reduce the root 3? The answer is no. Can't break down 3 any further. Can I break down 15? Well, I can to 3 and 5, but notice there's no pairs. So this is my final answer. With B, I'm going to do root 2 times the 4. That's 4 root 2. And the root 2 times the root 8. So that's going to be minus root 16. All right. Does everybody see where I got that from? Now, can I break down root 2? No, I can't. But I can break down root 16, right? Leah, what's the square root of 16? 4. So this would just be 4 root 2 minus 4. I could factor out a 4, but not about that today. Not about that today. Kaylin, when I'm doing C, I'm going to do root 6 times root 12. That's going to be root 72. Are you okay with that, Caleb? Now I'm going to do root 6 times root 3. That's going to be minus root 18. Now, Justin, you're pretty good at breaking these down, correct? What two numbers go into 72? 9 and 8. Two numbers that go into 9. There's a pair of 3s. Okay. What about 8, Justin? 4. And I have a pair of 2s. So this root 72, okay, I was able to pull a pair of 3s out and a pair of 2. So 3 and 2, I'm thinking 6. And I have the 2 left over. That's going to stay inside. So it's 6 root 2. You okay with that? Mike, you okay with this? Do you need a pen? There you go. Now root 18. Mike, can you give me two numbers that go into 18? Three, right? Okay, 6 and 3. Mike, can you give me two numbers that go into 6? And 2. Notice I have a pair of 3s right there. So root 18 is going to become 3 root 2. Mike, you all right with that? Now, Jake, I have 6 root 2 minus 3 root 2. They both have root 2s, right? Yeah. We were talking yesterday to treat those like roots as like a variable, correct? So if I said what's 6x minus 3x, you would say 3x. So 6 root 2 minus 3 root 2 is perfect, Jake. 3 root 2. Cody at home, you doing all right?
Yeah.
I'm looking for pairs of numbers. So because it was a square root, I'm looking for a pair. Right? If it was a cube root, I'm looking for a group of 3. Okay. All right, Lance. With A and B here, we're going to treat it just like we would with a FOIL problem. Like if this was x plus 2 times like x plus 3, right? We would multiply it out. Agreed? Same thing here. I'm going to just do FOIL. I'm going to do 2 root 7 times root 7. That's going to be 2 root 49. You okay with that? Then I'm going to do 2 root 7 times 1. That's going to be 2 root 7. Agreed? Now I'm going to do the negative 4 times root 7. That's negative 4 root 7. And I'm going to do negative 4 times 1, and that's going to be negative 4. Are you okay with where I got everything from? Now I'm going to start cleaning this up. Okay? 2 root 49. Square root of 49 is what, Lance? 7. So 2 times 7 is? So that 2 root 49 became 14. Now I have 2 root 7 minus 4 root 7. That's going to be minus 2 root 7. Jay, you still with me? And then at the end, I have a minus 4. So it's just going to be 10 minus 2 root 7. Everybody see how I was able to get to that answer? Okay. Now there are like shorter ways, right? Like root 7 times root 7. We can obviously see that they're going to undo each other, right? Root 7 times root 7 is root 7 squared, right? The square root and a square will undo each other. So that might be something you guys look out for. All right. But if not, you're certainly welcome to write it all out. All right, with B, I'm just going to FOIL here. I'm going to do 3 times 1. That's 3. I'm going to do 3 times root x. That's going to be 3 root x. I'm going to do negative x times 1. That's negative root x. And negative root x times root x. That's going to be negative root x squared. Right? Now, as I was just talking about it, right? The root 7 and root 7, they kind of undid each other. So here, the root x and root x are going to kind of undo each other. Yep. So I'm going to have 3. Then I have 3 root x minus root x. That's going to be plus 2 root x. And then I have negative root x squared. Well, that's just going to be negative x.
Where did you get this? Oh,
I haven't seen him. Yeah. So, yeah, I was trying to see what's up because I haven't seen him at all. He hasn't come after school or, yeah. So apparently he's been in the building. It's okay. No, not Mr. Monroe, Jake. That's Mr. Adams.
No, I thought you said if you were.
No, looking for somebody else. All right. Thank you. See, so Jake, where did I get the 2x? 3 root x minus root x. 2 root x.
Where did you get the x?
Negative root x times root x is negative root x squared, right? Because inside times inside, x times x would be x squared, and they undo each other.
How do they undo each other?
Well, because squaring and a square root undo each other, just like multiplication and division.
So, and then it reads it.
Mhm.
Okay.
All right. Now, this conjugate concept is actually pretty important. It'll come up again in physics. All right. Some of you might be taking it. Okay. I know some people might be taking chem instead. Okay. It doesn't really come up in chem, but it will possibly come up in physics or in pre-cal and trig, which is certainly something that you guys are going to be taking next year. So a conjugate basically is just, what it's used for is getting rid of square roots in the denominator, okay? So if I have something like this, Justin, okay? I'm just going to use the first one as an example, right? I have 1 over 1 minus root 3. Now, the problem with this is in math, we don't like certain things. We don't like decimals in the denominator. We don't like square roots in the denominator, right? We don't like complex fractions. We kind of like simplified things. So here, even though this is a numeric value and I can find that, I can type it in the calculator, we don't like it. Okay, so the problem becomes, how do I get rid of square roots in the denominator? All right, how do I do that? When it's 1 minus root 3. Well, the problem is we were talking about the other day, to rationalize the denominator, I would multiply it by like root 3 over root 3, right? So when we had this problem, I don't know if you guys recall it, it was something like 1 over, or no, it was like, it was yesterday. It was 5 over root 7. Do you guys remember that? I think it was yesterday. Julia, do you remember? Something like that. And then we multiplied by what? Root 7 over root 7. And this made the denominator a whole number. Leah, do you remember that? Chris? Something like that. All right. But with this, okay, when I have 1 over 1 minus root 3, kind of the problem is when I multiply by root 3 over root 3, okay, this is what happens. I have 1 times root 3 in the numerator. In the denominator, I have to distribute that. So it becomes root 3 minus 3. And I'm back to the same position, same place, right? I didn't get rid of the square root. So what this concept is all about, all right, it's called conjugates. So basically, kind of think of like when you have like a plus b times a minus b. When we did that, the middle canceled out. Do you guys remember that? When we had this, Justin, do you remember this? When we multiplied these two things together and the middle canceled out, right? We would have x times x is x squared. Then we would have x times 2, that was 2x. Negative 2 times x is negative 2x. Negative 2 times 2, that was negative 4. Then we saw those canceled out. Same principle going on here. But the concept is one's positive and one's negative. So the conjugate with square roots is, if I have 1 minus root 3, the conjugate is 1 plus root 3. If I have root 5 plus root 2, I have root 5 minus root 2. Hannah, do you see that?
Yeah.
All right, and then I have root 10 minus 3, and the conjugate is root 10 plus 3. And lastly, I have root x or plus 2 times root x minus 2. When I multiply each of these together, okay, if I do this times this, I have 1 times 1, that's going to be 1. And then I have 1 times root 3. And then I have negative root 3 times 1. And then I have negative root 3 times positive root 3, that's minus root 9. Here, look, those cancel out. I'm left with 1 minus 3, which is negative 2. Do you guys see that? Jay, do you see that? Yes. But the concept is, how do you determine what the conjugate is? All right, the conjugate is one is positive, one is negative. So that when I FOIL it, Jake, the middle goes away. So here, look, root 5 plus root 2 times root 5 minus root 2. This becomes root 5 times root 5, that's root 25. Then I have root 5 times negative root 2, that's negative root 10. Then I have root 2 times root 5, that's positive root 10. And then I have root 2 times negative root 2, that's negative root 4. But here, look, negative root 10, positive root 10, they cancel. Root 25 is 5, root 4 is 2, so I have 5 minus 2, which is 3. Lance, pretty easy, right? With this one, the more you do it, the easier it gets. All right, we're going to get root 100, and then I'm going to have plus 3 root 10 minus 3 root 10. And then I have minus 3 plus 3, that's minus 9. Notice these cancel. And I have 10 minus 9, which is 1. And the last problem, okay, when I FOIL that out, I'm going to get x minus 4. Jay, did you get it all done?
How did you get x minus 4?
FOIL it out, Jake. You want to do it? Be my guest. No, you can do it. Right? So all of that conjugate stuff is important for rationalizing the denominator. So if I need to rationalize the denominator, which are like these problems right here, I'm just going to multiply by 1 plus root 5 over 1 plus root 5. That's going to give me the numerator root 3 plus root 15 over, FOIL out the denominator. Okay, we're going to have 1, and then we're going to have plus root 5 minus root 5 minus root 25. Add, you with me? Add?
Yeah.
All right, you with me? You see where I'm getting this stuff from?
Yeah, I see it.
Okay. These cancel. And I have root 3 plus root 15 over 1 minus 5. And my answer would be root 3 plus root 15 over negative 4. Yes, Jack. I cannot. Okay, here's why. There's 2 reasons why. One, they're not the same radical, right? Okay, does that make sense to you? They're not the same radical, so I can't just combine them. The other way is probably going to seem sillier. Do you have your calculator? Okay, whenever I kind of have an intuition like, hey, can I do this? What I actually do, Jay, is I actually do it, see what happens. So Jay said, just so everybody can hear, can I combine the root 3 plus the root 15? So Jay, I want you to take in the square root of 3 and then hit the over button plus the square root of 15. You get a decimal, right? Don't tell me, it's probably like, I don't know, 5 point, yeah, it's almost like 6. It's 6. Yeah, okay, it's like 5 points. Got it? Now, Jay, what I want you to do is I want you to type in the square root of 18. Because 3 plus 15 is 18, right? Are they the same number? So then we can't do it. All right? I want you guys to try B. On your own, try to rationalize that denominator. Okay, I'll leave up A. So you guys can do it.
Wait, could you rationalize the first one?
We did, it. It's done.
Wait, you can't go anywhere else.
Nope, the problem's done.
Wait, if we do 5, 15, to 3, you get 18.
We just talked about that. We can't do it.
So why?
We just told you.
Why?
Because if you do it on a calculator, it doesn't work out in there. See if you can go to the next problem if you're done it. Okay. Did you get that? Almost there, Justin? Were you on your way to getting that?
Kind of.
Where did you get lost?
I got stuck at the part where
Okay, so you had 2 minus the square root of 3, and you should have 2 plus the square root of 3. Do you have that? The conjugate. So the conjugate, one should be plus, one should be minus. All right, now we're going to FOIL it. So we do the first, which is 2 times 10 to the 4th. Outer, okay, now this should be, see how you have minus and minus? Should be a plus. Okay, because that's what the conjugate is. All right, and then these cancel in the middle, and you're just left with 4 minus the square root of 9, which should be 4 minus 3. Yes, Jake?
like, can we FOIL the bottom part, like how would you set positive or negative?
Yeah, if the bottom's negative, then it's going to be a positive. Like here, see how it's root 7 plus root 2? I'm going to multiply it by root 7 minus root 2.
Oh, yeah.
Make sense? All right, see if you guys can do C. I gave you the conjugate, see if you can finish up with C. Get it, Troy? So You okay? Just kick it out. You got root 49, okay? Then root 7 times negative root 2. You have plus root 14 and then have minus. Got it? And see how the minus root 14 plus root 14 cancel? What's up? All right, let's look at C. So with C, I'm gonna have 5 root 2 times root 7, that's gonna be 5 root 14. 5 root 2 times negative root 2, that's gonna be negative 5 root 4, okay? I'm not trying to skip any steps here, I know, I can reduce that. Root 7 times root 7 is gonna be root 49. Root 7 times negative root 2 is negative root 14. Positive 2 times root 7 is positive root 14. And positive root 2 times negative root 2 is negative root 4. Here, this cancels with this. You good so far, Lance? Now, root 14. I can't simplify that, right, Leah? Root 14 is 2 and a 7. Doesn't really help. But root 4, Leah, what is the square root of 4? So 5 times 2 is 10. Is that okay with you? Over square root of 49 is 7. Square root of 4 is 2.
Where did you get
The square root of 4, dos. Cinco. How do you say times in Spanish?
math?
Anybody take Spanish?
I took Spanish for 2 years.
All right, here we go. Cinco y dos. 10.
Oh, oh,
So 5 times the square root of 4, square root of 4 is 2. 5 times 2 is 10. Now, Justin. Can't really do anything on top, but notice 7 minus 2 is 5. And here's the next step. Notice 5 can go into 5, right? 5 can go into 10. So I'm going to want to reduce that. 5 goes into 5 one time, so I have root 14. 5 goes into 10 2 times, so my answer is just root 14 minus 2. You guys okay with that? All right, I want you guys to try D and whatever the last one is. You can do that for homework or whatnot. I'll put up the next web assign stuff. All right. So again, we're gonna have a bunch of web assigns due. We're gonna do web assigns tomorrow. We're gonna have reviews. All right, but I'm thinking review next week and test on Tuesday.